There we go. We're recording.
Good. I can cut the beginning of the video out easily.
Nope. Actually, you'll see a video of me up there. But, I think so. Yeah, yeah. I just do a little, like, what's going on, show this guy, like, what can you see? Just general type stuff. Oh, yeah. Isn't it great? Where do you live? Oh, right around here? Okay. Oh, really? It's not the same way.
We're going to go first through the normal procedure type stuff, then we always do all of stuff, then we'll do you, and then yeah, it works out real well. Yep. So you want to grab a seat in front here, after I do that, we'll watch the video. I'll give you this. Okay. That's the 8-inch dose.
And where was this?
How are we doing, Dave? Dave.
Your name is Dave?
Chuck, I'm Dave. Good, nice to meet you. I am one of the presenters today. I just myself and I. So, thanks for coming out.
I usually
Yeah,
I'm done
actually,
for the person in August. Yeah, it's in August. Yeah, it's like 16, 17. I don't memorize dates, that's why I read it. But usually, like when I go, I had clear skies, but I don't know. You want to look north? And I'm down in Wildwood or Wildwood Crest. All of Wildwood.
Hey, how are you doing? Yeah, very well. How are you? Pretty good. Thanks for coming
All
out. Juno.
everything. So I don't see as much.
Let's go.
Yeah.
We'll see, we're going to try to cut this out so we can got a little cutting nice there, thing, right? There's landlords telling us if it's got to cooperate with us. Yeah. So I'll pop to him quick before we get started. Does it look like we're going to be good tonight? Are there any observations? Or?
We won't know until the time.
All right. I'll wait on your. Give me a thumbs up. Or I guess otherwise I'll. I keep talking, but I don't want to do that if I don't want to start. I want to like last half hour, like 7:30 or so. I'd like to be.
Okay.
Right.
Well, keep in mind, the sun doesn't set until 8:20.
Okay. True. Okay.
So
So I'll go to 8.
I assume we go to 8, as
Okay.
we usually do.
Works for me.
Hey, Ted.
How are you doing? Works for me.
All right.
Smart fall stuff is not that bad.
How you doing? Thanks for coming out. What's up? I got rid of the crutches. I do have a cane over there if I need
What
it.
show is that?
I'm kind of like right on the edge of.
Nice.
I'm still doing physical therapy. Yeah. So I had surgery in June, and I'm at 7 weeks in. So hoping to make it to the school year. The school year starts, I hope to, not 100%, but 95%. Hey, how are we doing? Oh, hi. Nice to meet you. So you got the thing for Middle Creek, right?
Yeah, that's great, thank you. Yeah, it's nice to see you walking.
We got access to the
Oh, really?
and I got like, all the people who are just you were to join, yeah. If you were to join, it's $10.
Depends on how tall you
You would have access to the street light bars.
I was just gonna cut your head off.
Is that all?
I'll tell you about another thing.
Well, I'm a sloucher, so I can slouch.
Oh,
that,
okay.
Southern Lights. Right. There's another astronomy company that they need to go in. Okay.
Oh, yeah?
You can be my surrogate there. I'll like forward information through you. Give me my channels. All right.
Oh, last night.
Man.
That's really what.
It's good. It's tough when people just.
Just turn it down a little bit. Is that a little louder, or are we good? Does everybody think this is a good level? Too loud? I agree. Let's turn it down more.
Yeah.
Not too important things.
All right. How's that?
Still too loud.
Still too loud. How much are we at there, Lane?
It's almost off.
It's almost off. Here, let me see if this has a way to.
Turn it down.
Yeah, all the way off. That's good. It's in part for your hearing me, but also in part for the video that we do. It's a lot better.
Try moving the mic down from under your chin to somewhere else.
Good call. Thank you. I will do that.
Okay, I think it's about to get better with 13 inch. Very easy way out with that.
How about now? That's a lot better. Okay. Good evening, everyone. Thank you for coming out. I see a lot of new faces out this evening. Who has never attended a meeting before? Just so I can get a show of hands. Awesome. All right. Thank you for coming out. I am Dave Farina. I am the Astronomy Enthusiast at Lancaster County Club President. We also have in attendance tonight Lane Davis, who is walking in the back there. Lane is the club Vice President. We also have Rob Webb, who is going to be doing our observing with Webb. And we also have a way that you can contact us here on our internet connection would help. Just do that quick.
The joys of technology.
You guys just didn't know, if you do that and you don't have an internet connection and you see that little dinosaur, you know what you can do? Hit the space bar and there's a game. You can play a game. So I was just showing you the really cool feature there. All right, now we're logged in. Let's try that again. Okay, so yeah, if you would like to get in contact with any of our officers or cabinet members, right under the contact on our main page is right there. There's my email. There's Lane's email. Lane is also the person in charge of Star Watches. So if you're interested in ever attending a Star Watch with telescopes, we do a number of events throughout the year. We have, I believe, 4 more coming.
Yes.
4 more for the remainder of this year. We do hibernate in the winter. We don't go out and do public star watches during the winter because it's just simply too cold. Although there's some really good skies in the winter, so if you're interested, in seeing the night sky in the winter, members do continue to do astronomy, but we just don't do the public stuff because the weather is a little bit chilly. And we just don't get turnout. Tom Lugar is our club treasurer. He's not here this evening. And James is in the back. He's our club secretary. We also tonight have one of our cabinet members, Axel Diaz. Axel is going to be presenting with me this evening. Axel is new to AELC, and he's our solar system ambassador, one of two. I'm the other one. And I have a link to that in our talking points for the night. So last here is Rob Webb as well. As I told you already, Rob does the Observing with Webb, and Rob's been doing this for a number of years now. And you can actually go to the place Observing with Webb. Did you know I did that, Rob?
Yes, we did.
Yeah, right up top here now you can get directly to the Observing with Webb for each month. And Rob does these awesome videos which talk about what's up in the sky for this month. And I'm going to play that right now.
Hi, everybody. Welcome to Observing with Webb for August of 2016. This August is going to be pretty cool because not only do we have our normal Perseid meteor shower, which is always a good one, barring that we need some time, but we've got the Perseid meteor shower. We've got all 5 planets visible, at least in the beginning of the month, if you have binoculars. And we also have 2 close encounters with planets that should really be pretty cool to look at. So I'm going to show you what that looks like over here on the computer. And I'm going to go over the planets that we can see in 2 big clusters. And I'm going to talk about the events, including the meteor shower. And if you're wondering about the occultation, I'm not going to go over the occultation of Aldebaran, so you'll have to look that up yourself. But I'm going to go over some of the other stuff. So anyway, planets. What are you going to see with your naked eye? Well, if you take a look, let me put this back to August 1st, and I'm going to go to sunset. And what you notice over here in the west is a nice conglomeration of Mercury, Venus, and Jupiter. Okay? Now, this is the one cluster of 3 planets that you can see after sunset. So Venus, Mercury, and Jupiter. Now, Venus is going to be pretty bright. It's the brightest one out there. Has a very high magnitude. But it's still going to be hard to see because it's close to the sun. It's still dusk. The very beginning of dusk, when you might be able to see it. Mercury is going to be very dim comparatively. You're probably not going to be able to see it with your naked eye, but you might for the first half of the month. And then there's Jupiter up here, which is kind of in between in brightness, but it's brighter. You should be able to see it with your naked eye, no problem. So, what's going to happen throughout the month with these planets? Let's take a look. So let's just go at 8:20 p.m. And as we fast forward through the days, each day, ignore the moon for that, each day Jupiter gets a little bit closer. Venus and Mercury, it's a little bit darker at 8:20, and they're about the same, maybe a little bit lower in the sky. Let me change sunset. There we go, at sunset, a little higher in the sky. And what you'll notice is that Jupiter is creeping in a bit, okay? Well, let me back up to the 10th real quick. On the 10th, I like the 10th because Mercury is almost right in the middle between Jupiter and Venus. So it should be easier to find Mercury since you know exactly where it's going to be. But Jupiter keeps getting closer and closer throughout the month. And let's see, I have it down, right around the 22nd. They form a nice triangle down there in the western horizon. Again, Mercury is going to be tough because it's dim and low. Venus and Jupiter will be much, much easier because they'll be higher and brighter. And on the 27th, and I'll just get this out of the way right now, Jupiter and Venus are really, really close together. I don't think I've seen them this close together before. But let's see. On the 26th, Jupiter and Venus are over here, And then on the next day, they are much, much closer. In fact, so close that you should be able to get Venus and Jupiter in the same telescope eyepiece, in the same field. Okay? Let's see if I can center my Jupiter there. Okay? Now, the problem is going to be, we're taking a picture, Venus is going to be much, much brighter than Jupiter. So I'm guessing if you try to take pictures of this through your telescope, if you want to get surface features of Jupiter, you're not going to see the moons, and Venus will be super, super bright. Okay? But hey, I don't know, I'm not a great astrophotographer, Lane is, so Lane, here's your challenge. Get a good picture. Okay? But anyway, that's the closest I've seen them. It's less than 1/10 of a degree apart. Get your binoculars out. Your eyes are going to be able to see much more than the camera in a sense, at least just looking. You should be able to see both Venus and Jupiter, although Venus will still be very bright. Your eyes adjust for contrast a lot better than the camera does. So anyways, those are the planets off in the west. Okay? Pretty much after that, you can't see Venus or Jupiter for a little while. All right? On the other side, well, sort of other side, at least in the west, so let me go back to the first. If you're looking for planets, let's go a little bit later. Let's say we go to 9 o'clock, after you've looked at those western ones. You'll see Saturn and Mars up here. Okay? So you'll see also the bright star Antares down here. Okay? Saturn's up here, Mars is over here. And let me zoom in a bit. Okay? So off in the west, you'll be able to see these guys. And what you'll notice, let me set on it. Okay. What you'll notice is, as you go along, okay, they start off on the first, about 11 degrees apart. What you'll notice is that Saturn sort of overtakes Mars, or really, as I'm seeing now, Mars is sort of invading in between Saturn and Antares. What you'll see is they keep getting closer and closer together, okay, until the 23rd and the 24th. Now, this is a great event as well. On the 23rd and the 24th, 23rd, 24th, 23rd, and 24th, you'll notice that Saturn, Mars, and Antares make a nice, neat line. And this is about the time when they get as close to each other as they will, at least for this pass. They're about 4 degrees apart there. It's 4 pinky widths, or probably about, if you hold 3 fingers up like this, a little less than that. But at the end of the month, Mars will have trekked through and now is on the opposite side. And they're about, I think, 5 degrees apart at that point. But they're still out there, still looking really cool. So if we rewind, fast forward. All right, so those are the planets. Oh, by the way, Mars and Saturn, you'll be able to see them all the way to about 11:30. Okay? You won't be able to see them after that. So if you want to look at planets, get out before 11:30. Let's go back to some events. Okay? And on the 2nd of August is the new moon. That means that the moon is not visible at all from our perspective. It's over by the sun down here. And as we know, the moon is going to start becoming a waxing crescent after that. Now let's go back here to the Venus, Mercury, Jupiter area. And what you'll see is on August 4th, Mercury and the moon will be close together, close encounter. It'll be tough to see again because Mercury is dim and the moon is super dim as well. But if you have binoculars, a nice good view of the western horizon, I think you can see that, and I think it'll be pretty cool. The moon is probably easier than Mercury. Yeah, it's definitely easier than Mercury to see that. Okay? But the next day, on the 5th, the waxing crescent moon is a little bit thicker, a little bit higher, and is closer to Jupiter. I believe they are only about 2 degrees apart. And they set around 9:30 p.m. So if you are looking for Jupiter and Mercury and you've been having trouble, look on the 4th for the moon and Mercury will be nearby. And look on the 5th for the moon and Jupiter will be nearby. The moon is a great guidepost in that sense. Okay? Now, as if you're in the AELC and watching this, you'll know that the moon gets thicker and thicker and higher in the sky until the 10th, which is when you have the first quarter moon. That means that the right side is visible. It's up there for until about midnight, let's say. We move to 9 o'clock. And you'll notice it's starting to get closer to Saturn and Mars. And the other close encounter with the moon is this one on the 11th and 12th. And as you can see, the moon makes a nice triangle with Mars and Saturn. Remember, Mars is going to be that reddish one down below. Saturn is going to be more cream colored and to the left. And you can also include Antares in this, and you see that they make a pretty cool diamond-looking shape in the sky if you include Antares. Then on the next night, August 12th, you've got Mars, Saturn, and the moon making almost a straight line in the night sky, which is pretty neat as well. Let's see. Moving on from there, 12th and 13th. That is the Perseid meteor shower. Now, what's going on with the Perseid meteor shower? Tough luck, there's a gibbous moon, so we won't get any sunset watching, or evening watching. We have to go to the early morning. Now, where do you look? First of all, well, you gotta look, really you wanna look at the entire sky. You kinda wanna look north, in the northeast direction, because the northeast direction, remember the moon's still up, so we've gotta wait until about midnight. And after midnight, you're gonna start seeing Perseus over here, that constellation rising. Now, you don't wanna look right at Perseus. You want to look around at the whole sky because that's the radiance. That's where the meteors will be coming from or appear to be coming from based on our orbit. Okay, so you want to be looking at the whole sky. Okay? Now, is this going to be a good year for the Perseus? Let me explain again. This should be a really good one because the astrophysicists are saying that count of 60 to 90. That's a really good count for meteors. 60 to 90 meters per hour, it will probably be even higher this year. Why? I'm just going to say there's some issues with Jupiter and its gravitational pull in the orbit of the comet, Swift-Tuttle. Remember, what you're really seeing with the meteor is the debris from comet Swift-Tuttle moving and hitting the Earth at 37 miles per second. That's why they crash into the atmosphere, crush the air in front of it, heat up the air, heat up itself, and burn in the atmosphere because it's hitting air 37 miles per second. Anyway, with the orbit of Earth, with the orbit of the comet, with the orbit of Jupiter, they interact sometimes, and Jupiter will sort of mess up and sort of give us a little extra boost, or give the comet material an extra boost. I bet you Dave will have a better explanation of that, but I just say blame Jupiter and you're good. So anyway, you're saying it could be more than that? It's probably going to be more than that, and in fact could be even double if everything holds true. But we know how astronomers sometimes inflate expectations. Anyway, other advice for this, make sure you find a dark location. That's probably your key here. Because if you can get away from general light pollution, away from cities, that's a really good first step. If you can't do that, then at least get away from the local light pollution. Make sure there's no street lights nearby. Make sure there's no house lights nearby. Find the most shady area in your house or in your development or anywhere. Don't go near a neighbor's house unless they know. Okay, similar rules to Pokemon Go. Okay, but what you can do is find a dark spot, let your eyes adapt, get like a swimming pool floaty or some sort of chair that you can just sit on and just look at the sky the entire night. And check the weather. Before you even do that, check the weather to make sure. Scattered storms, not usually a big deal because they come and go, but the long periods of rain and clouds, not a good idea. So check the weather. Also, get out there after midnight. You might actually see, just because you can't go out after midnight doesn't mean you won't see some of these. It is active from about mid-July to late August, so you might actually see some Perseids here and there. Okay? And also, you can go to Sky and Telescope or the International Meteor Organization to find some ways to actually do a meteor count. In fact, you want to help with citizen science, which is pretty cool. Anyway, that's the Perseid meteor shower. I know not much to show on screen, but you know. Yeah, so that's the 14th. Let's move on. Let me go back and look south. And so we're looking at midnight. So, to the 18th. 18th is the full moon. That means the moon is visible all night and is fully lit up. And not much happens until the 23rd and the 24th. And we already went over that. On the 23rd and 24th, rewind, you'll see Saturn and Mars in the south, sort of lining up with Antares. And then the last quarter moon is on the 24th. That's when the left half of the moon is lit up. Time. The left half of the moon is lit up. Doesn't rise until about midnight, 1 a.m. and is visible into the morning. And then also on the 27th, like we said before, let's go back to sunset. On the 27th, let's look in the west. That's when you find Venus and Jupiter super duper close together. Yeah, so that's what's going on for August. Last thing that I'll leave you with is a quick look at some constellations. Nope, I'm at 15 minutes, so I think I might skip that, other than to say, if you look past 9 o'clock and you're looking at Saturn and Mars, you can also take some time to look at this area up here, especially those of you with binoculars or a telescope. Sagittarius, find that teapot part of Sagittarius, and you can find plenty of naked eye or binocular targets, such as the butterfly cluster, that's pretty bright, the Lagoon Nebula, the Trifid Nebula, you might see the Eagle Nebula, that's a little darker, M23, M25 is a good one, that's an open cluster. Lots of really cool stuff in that area, because that's the part of the galaxy that, that's the center of the galaxy that we're looking at. So there are a lot more interesting things at that end. So anyway, with that, I wish you guys all very clear dark skies, especially for the Perseid meteor shower, but for the month of August.
All right, thank you very much, Rob. Does anyone have questions for Rob while he's here this evening? Anything that you saw and have questions about, or any things you'd like to see in the future?
Is there any way you can come up with screenshots of those?
I mean, I can take pictures of whatever's on my screen. Yeah, what?
Just so we have some reference.
Like some sort of paper to hand out?
Right.
If you go to our Observing with Web page, it says here to listen to this Observing with Web as a podcast and read it in HTML, you click here. It'll bring you to this site. Now that may be changing, and I'll change the link if it changes.
Not, but
Okay.
yeah, I do have the text up there. It's not pictures, but it's text. Down at the very bottom of that, there's something. There's a link for skymaps.com.
Okay.
They put out every month. They put out what the constellations look like and where the planets are for about 8 p.m.
Okay.
for that month.
Yeah, Sky Maps is
probably be
100% free,
Okay.
and yeah, that's our recommendation. I believe it's on our links page as well.
That's a very good place. And they also have some of the things that are going on through the month too. So
Yeah, and then I think it's usually, well, every time I've printed it at least, it's always the front side is a planisphere, and the back side is the happenings of that month with the objects that you can see. It's always one page front and back. It's a really nice way to do it.
Axel, you had something?
Yes, you mentioned that at 27 we can see Jupiter and Venus at the same time.
Mm-hmm.
So we can see both in the eyepiece at the same time?
Yes.
Okay.
Which is very unusual. Very unusual.
Use your, on your eyepiece, the number on the eyepiece should be the higher number. Keep in mind, for those of you just getting into astronomy, If you're using a telescope, the eyepiece is what provides you the magnification or zoom. And the bigger the number, the lower the amount of zoom you have. The smaller that number, the more magnification you'll have. So you'd want to go with the bigger of the numbers on the eyepieces if you have a telescope.
And as you go through it, if you are watching the video and you think, I've got a much better title than observing with web, that's really lame, please send me, I've been trying to think about a new title, but my attention span is very small. So
I like it. See, I actually, I'm thinking, I might just have to start doing some of this too. Good.
Competition, I'll take you out. Yeah.
What software are you using for that?
The software is called Starry Night. That's what I am taking recordings of. The recording software that I use to record what's on my screen and my face at the same time is, and I've been using it for how many years? ScreenFlow.
Yeah.
That's what it's called, ScreenFlow. It's about $100.
There's free ones out there as well. If you're interested, we'll talk about it afterward.
Yeah.
Between those dates of mid-July and late August, is there a peak in there or any way of knowing?
The 12th to the 13th is the peak.
Okay, and hours of the night?
I would go out after midnight because, one, the moon will be set, and I believe that's when the peak is happening as well. But yeah, your best bet is the night of the 12th, morning of the 13th. After midnight, between midnight and like 5 a.m. is when it starts getting bright again. So that's your best bet. I know, worst time, the time you definitely want to be sleeping. Yeah.
Is that the Perseus meteor shower, is that low in the horizon?
It'll be low in the horizon around midnight, but throughout the night it's going to get much higher. Well, the radiant is going to get much higher. And as the radiant, which is the place that they appear to be coming from, as that gets higher and higher, you should be able to see more. Because you're not just, when it's low in the horizon, you're just getting the ones going up. When it's higher, you're getting the ones that are going that direction, up before, and down as well. So.
Keep in mind, there are software out there that are free. Stellarium, for instance, is one. This is Starry Night. This is what Rob was using. But Stellarium here is free. Does pretty much the same thing. And I just wanted to pull this up to show where basically you need to be looking. But like Rob said, if you lay on your back to do this, you're going to see the meteors coming from this location, which we say Perseus, or from the constellation Perseus, but you'll see them throughout the whole night sky. So let's go to midnight. And we'll turn on the constellations here. Just get that thing out of there. Whatever. So you're going to be wanting to look towards Perseus. Okay, where am I at here?
Just hit and keep going. There you go.
There we go. So if you look here, that's the northeast. But you can think of it like driving. I liken it to driving through a bunch of bugs, or in a snowstorm where all the snow looks like it's coming at you while you're driving, especially at night with headlights on. That's essentially what the Earth is doing. The Earth is flying through a cloud of debris that's been left behind by a comet. And so as we fly through that, this Perseus part of the sky is essentially like the car's windshield, right? So if you look out your windshield, of course everything looks like it's coming at you, but if you look at the side of your car window, you'd still see the snow, right? And it would be moving laterally with your car and the motion of your car. That's essentially what's happening here. So if you're moving, this is where most of them are going to be coming from. It's called the radiant. But you're going to see meteors here, you're going to see meteors here, and the best bet is just to lay down and look straight up. Any other questions for me or Rob about anything you saw in the observing with web? Your question? No? Okay. All right, folks. Being that we have some people that are new in the audience, I just want to take a second here again to remind you that you can follow along if you'd like. under the Meetings tab, if you have a smartphone or laptop along with you, and you go to the Shared File. This should be open to everybody. Go to Meeting Lecture Files. So once again, that's Meetings, Shared File, Meeting Lecture Files, and it'll pull up this page. And you click on, these are all previously done events, or I should say discussions. Today is Juno 7/3/16, that's the date I made it, I guess. Should be 8/3. Juno talking points. So I'm going to be following this tonight. We also have Axel Diaz this evening, and I didn't get a chance to get Axel's presentation, but I will put it in the same folder. So I will get that in there shortly. Axel is NASA Solar System Ambassador. You can find out more about his background here. And he's also, as I said, new to our club as our social media coordinator. I am also a Solar System Ambassador, and we're going to be co-presenting this evening on a very important and groundbreaking mission to Jupiter called Juno. So without further ado, I introduce Axel Diaz. Come on. And if you just hit forward or back. Okay.
Yes, hi. Thank you, Dave. Oh, guys, thank you. Thank you, Dave. We're talking about Juno, not the movie. People say Juno's the movie. That's movie. It's Juno, the spacecraft. In 2011, NASA sent the spacecraft to Juno. It took 5 years to get there, 5 years. And finally, in 2016, on July 4, get there. Juno means a wife of Jupiter in the Greek mythology. That's why NASA chose that name, Juno, for this spacecraft that was launched again in 2011. If you want to know the size of Juno, I'm scared, that's the size of Juno. It's basically the size of the basketball court. That's the size of Juno. And basically, this section here, right in the middle here, measures 11 by 11. The section where we have all the instruments of Juno. And the solar panels, they measure 29 feet long each. So the total weight of the whole thing is about 8,000 pounds. That's how much weight is spacecraft Juno. You can see there the size of the spacecraft. If you go here, how fast Juno is going, or how fast Juno was going, when Juno was launched, like I said before, 5 years ago, was launched at 17,000 miles an hour, that way to break the gravity from the Earth. But when Juno was getting there to Jupiter, how fast was going? 165,000 miles an hour. It's the fastest thing that ever NASA sent to space. So before Juno got to orbit in Jupiter, they had to basically hit the brakes before get there. So they had to start the engine to slow down the spacecraft to then get into the orbit with Jupiter. But how fast, you can see here how fast the space shuttle was. Space shuttle, a bicycle 70 miles an hour. But imagine doing that. 165,000 miles an hour. How fast was going?
Is that how fast you ride a bike?
That's it, right?
That's faster than I can ride.
You can put a motorcycle. You can see here, Juno, this that's from NASA. Again, here you can see here the size of Juno. But the next picture, we can see more clearly all the instruments from Juno. Especially, you can see here the panels, like I mentioned before, because it's so far from the sun, that it needs these big panels for power. So without that, it can have any power. And Juno is going to be in Jupiter for 20 months. It's going to be there for 20 months. So you need all this power to be there for that long. You can see here we have 8 instrument, the most important instrument from Juno, here. You can see here number one to measure the gravity of Juno, one to measure the microwave of the planets, magnetometer here, one to measure the particles, and so on here. But my favorite instrument here is number 8. It's going to be the Juno cam. And the Juno cam is going to be open their eyes maybe in the next few months. So you can see clearly more closer the planet Jupiter. When they finally open the eyes, I think it's going to be 3,000 miles above Jupiter. It's going to be that close there. So we can see the great red spot from Jupiter. I'm looking forward to see that. Well, that's the main 8 instrument that we have inside here, inside the spacecraft of Juno. You can see also here the day that was launched, August 5th. Make a few orbits around the Earth. They finally got to Jupiter and Jupiter, July 4, 2016. And here we can see, maybe people doesn't know this, but NASA have spacecraft passengers in the spacecraft Juno. We have here Juno, Jupiter, Juno, and Galileo. That's the Lego figurines that inside the spacecraft, and NASA did that in partner with Lego to create awareness in children, to create interest in science. That's why NASA did that. So they're there inside the spacecraft. All those Lego figurines inside the Juno spacecraft. So that's all I have for today. So far, I want you to know how much about the spacecraft. If you have any question that I can answer, let me know. If not, any question about the spacecraft? Yes?
The special figurines, they look silver. Are they made of silver?
No, they're plastic.
It's plastic.
Yeah, it's that normal size. It's a Lego figurines. They're small, tiny Lego figurines.
Yeah, actually, they did make them out of metal.
That metal?
They were originally cast in plastic, and then the scientists at NASA said that's not going to be okay.
Oh.
Because you were right, you can get them, I think, even.
That I'm not sure. So you can
Plastic,
get it.
but yeah, they're metal.
What were they for?
Therefore, they want NASA to create awareness to children, so they can learn more about science. So they know we have Lego figurines there, Lego. Something just, maybe something silly NASA did there. Yes.
What will happen to the spacecraft once the mission is completed?
It's going to crash into the Jupiter.
Will it?
Yeah.
Okay.
Yeah, we'll talk a little bit more about that then.
It's only 20 months, mission 20 months. Yeah.
How difficult was it to bring it to 165,000?
Yeah, they have some.
Sequences?
Yeah, they have some engines. They had to start the engines before, just to slow down the spacecraft. But they had to start the engines. As a matter of fact, that night when they have that live, that was the concern. Make sure the engines start the engines so they can slow down the spacecraft. Yes.
How much did Juno cost?
That I don't remember how much it costs. I know it's expensive. What's expensive? I forgot the exact number. I forgot exactly. No. Yes.
I wonder why, do you have any idea, like, why Juno has those Lego mediums, like, those Lego medium figures? Because to me, they seem to represent something.
Yes. Like I said before, they have the same Jupiter, the first one, Juno, and Galileo.
Yeah.
That's what they are. That's Jupiter. This is Juno. That's Galileo.
It's a Santa Claus.
Yeah, so Jupiter is also known as Zeus, right? Depends on which mythology you're looking at. Yeah, Galileo's got
Oh, Galileo, yeah, exactly.
Yeah, so Galileo, Jupiter or Zeus.
Yeah, that's like, and Juno.
And Juno is his
Wife of Jupiter.
Yeah. So it's fun.
Yeah.
Yeah.
Yes.
So has it started taking pictures of Jupiter, or are they on the NASA website?
Yeah, I took a few pictures.
We're going to talk about it.
Yeah.
Yep.
Are you going to go into the various flyballs?
Yes.
That's 1.1 billion.
That much go.
Cost.
Yeah.
We're glad it didn't burn up on the first entry.
Right, yeah.
Yes.
Or, well,
And that was, because that was the concern.
oh yeah,
Yeah, after 5 years.
then everything turns on.
Yeah. Yes.
It's probably a little difficult to define the surface of Jupiter, but how far above the planet is the
We're gonna get it.
satellite?
Yeah.
I'll give you that too.
Okay, thank you.
All right, thank you very much, Axel. So, as I said, you can follow along, and I will post this PowerPoint up on the same folder here for the Juno talking points. I'm going to be doing it a little bit differently than just a PowerPoint presentation, because I'm never going to be able to cover all of these topics in their entirety. And this way, you can access this document. You can find the same websites that I'm on tonight or at a later date and be able to delve deeper, because we're just going to be scratching the surface this evening. And if at any time you have any questions, please don't not ask them. I want people talking. I want this to be a discussion. So please just raise your hand or just ask the question. So first, we do have something I'm trying to promote here, which is our Facebook page. So if you are interested in trying to get the word out, maybe friends and family that you know, please share these events on Facebook. Join our Facebook group. This is a way we're trying to make sure we get the word out about these events. So please check that out. And it's just Astronomy Enthusiasts of Lancaster County on Facebook. So, first link tonight is a message from NASA via YouTube.
That's really cool.
Okay, there we go. I'm going to start that over again. We've now had a successful Jupiter orbit insertion. The biggest and most worrying part about this is past us. So now we are in Jupiter's gravity, and we are in orbit, and those orbits are going to take approximately 53.5 days. And I'm actually going to jump to this website here, Juno CAN website, in a moment, but I actually listed these for my purposes here. The first orbit after that initial insertion, which was July 4th, will be on August 27th, this month. And the purpose of this first, what they're calling perigove, so for instance, if you're in the closest part of your orbit to a given body, like the Earth, for instance, it would be perigee. G being like geo, like the Earth. If you're near the sun, it would be perihelion. Helios is our sun, right? In this case, Jove is Jovian, which is Jupiter-like planets. So the first perigove from that initial date, which was on, once again, July 4th, is this August 27th. Now, the first time around is going to be for calibration of the instruments. They're just going to be testing things out, trying to work out any bugs that they have, and make sure that when they start to do science, can you turn that back down, Lane? Please.
I have no control over it.
But you turned it back up for the video, I think?
It is.
Oh, okay, it's back down again? All right. So the second one is on, is going to continue to be on this longer orbit. So here it says 53.5 days to go around once. But that's not the final placement. They're going to be doing another burn of the engines one last time. And this is an orbit modification. So what you do is you basically, if you're going around in orbit, can I have a volunteer? One up. Okay. So you're going to be Jupiter. Your name is?
My name is William Floping, and I was born October 12, 2001.
Excellent. All right. So, William, we're going to be acting as Jupiter here. You're the biggest planet. Let's make it big. Okay? All right. So, I'm Juno. Now, when I'm at what would be apogee, which is the farthest part of my orbit, I'm far away. But then I do have, not a circular orbit, right? It's an orbit that is elliptical. And so at some point, I'm going to be closer to Jupiter. Notice how I'm much closer now. This would be perigove. This would be when my orbit is closest. And what they do is they're going to wait until it goes around that second time. And they're going to, if I'm going around in this direction, let's get around once. Here's my first orbit. I'm calibrating my instruments. Second time through, now I'm at apogee. Second perigove. We're moving in this direction. So what I want to do is I want to use my rockets against the direction that I'm moving in to slow myself down. And you do that always at the perigove, or if you're going around the sun, it would be perihelion, right? And you burn to slow things down, and then what happens is now the spacecraft is not going fast enough to go way out here, and so as now it's trying to leave, Jupiter's gravity is still pulling on it, and it's now created a smaller orbit. Yes?
Does NASA ever lose communication with the satellite when it goes behind the planet?
I would imagine that they would. I don't know for sure, but I don't know of any satellites that we have farther out to do any communication. Lane, do you have an answer?
In the case of Juno, it's a pole-to-pole orbit.
True.
So we see the entire orbit all
You do?
the time.
Okay.
But in previous probes we have at Jupiter, where it was equator-wise, yeah, we would lose it as it went behind Jupiter.
Okay.
Yes?
Is this probe going to be closer to Jupiter than Jupiter's moons, or further away, or?
I believe it's farther, but I'd have to double check that. We can actually look at that. I'll show you a visualization in a few minutes.
Oh, what was that?
That was me. I apologize. All right. Thank you very much. Let's give him a round of applause. All right. So now that we're in this smaller orbit, notice our days for the orbital period, the time it takes to go around once, has dropped to 14 days. That is a lot better for the sake of the fact that the whole idea here is to be in orbit around Jupiter and take data from its surface. Not only is the period going to be shorter, it's also going to be a lot closer. And so now our next level of calibration and testing is going to happen on Parajove 3, which, if this is happening on, point being, by November, we're going to do our first science. Okay? So July to November, that's the time period NASA gets to play around with the instruments before it starts to matter. This is when to make your mistakes. And they will make them. And that's one of the things, especially for the kids, I teach high school, that they just don't understand. Like, we all make mistakes, and that's a good thing, because that's, as long as you can make those mistakes early enough, you can fix them. NASA's going to make tons of mistakes from now until Juno's science time. Then you're hoping that you have everything figured out, because you have $1 billion plus on the line here that we spent on this. So hopefully we get it right. That's a lot of pressure, but they will make mistakes, I guarantee you. Hopefully they're not big ones. And their first chance here to make a big mistake, they didn't. They got it in orbit, and it's doing what it's supposed to do. So far, so good. So the first science and imaging starts for Juno Cam. And this is where we're going to go next on our little trip here, is to this website. And Axel talked a little bit about Juno Cam as one of the 8 instruments that Juno has on board. And to be quite honest, in terms of science, Juno Cam is not for science.
What do you mean?
That the cameras on Juno are not meant to be scientific instruments. They're public outreach. That is their main goal. Carl Sagan, very, very famous NASA scientist or Caltech scientist and NASA collaborator, worked on early missions to the solar system, figured out that the public really needs to be on board with this. And NASA has continued this trend up until Juno and other missions. You may have, has anybody ever gotten a chance to look at anything with the Mars rover? It tweets, right? It sends out messages to the public. That's got no scientific value whatsoever. But we realize that the public has interest, and if without public interest, we can't get the funding. So this is for you. And as a result, they have this voting section. And in November, the voting starts. And what are you voting on? You're voting on this information here. Let's go back. You're voting on which part of the planet's surface in each of these little circles represents an area of interest. Happy equator. And people, like, these are actually from the public. Red spot, of course, look at them all around the red spot. Lots of different people who are interested in seeing this. Okay? And you can click for more information on any of them. Some people are interested about what's going on up here in the polar regions.
Whoa. Ooh, that's cool. So that you can only do science with this infrared aurora app.
Well, they're going to have lots of different stuff, and I'm glad you brought up the aurora, because that's probably why people are interested in this. Jupiter has the biggest magnetic field in the solar system, other than our sun. And as a result, it has one of the most magnificent aurora in the solar system, and we are, for the first time ever, as Lane was saying, going to have a spacecraft doing a polar orbit. And what that literally means is we're going to go up and over its poles. And we'll talk a little bit about why that is in a few minutes. And as a result, we're going to be able to see those aurora. So glad you brought that up. And if you're interested in learning more about those aurora, you should come onto this website and you should vote, starting in November, that you want to see more aurora pictures. Who's going to be doing a vote? I know I am. Awesome. All right, good. All right, so there's also going to be a discussion page at this point. This is actually where I got some of the information from. I don't just make this stuff up, folks. Whoever this person is, Candy, a Juno specialist, wrote all about this information. And when I got those parajoves, there it is. I didn't make this up. Okay, 14-day orbit. After that, PJ3, Parajove 3. We'll do more testing. This is where I got that information from. So she and other people are going to be adding comments on here so that you can follow along. And from what I understand, when you click on something, let's see if we can click on the great red spot. Great red spot. Red spot. Okay, click here for more information. You can actually get, I hope they're going to give you more information than a very long-lasting storm. Right?
That's awesome.
But as they gather more data, as they find out more things on Jupiter, this is going to be their way of communicating that information to the general public. So this is, I would keep track of this. If I were you, want to learn more about this, this is where all the cool things are going to be placed for public consumption. Any questions on this before we move to a new place on the topics? Yes, sir.
So you're only gonna use the infrared mapper before you use the Juno cam?
All of the instruments will be used. I don't think it's a matter of that nobody in the scientific community will use the Juno cam. I'm sure some people will. But the other 7 instruments are better for the purposes of science. We can learn more from the instruments than we can from the pictures. Okay? But together, combined with the pictures, can tell us a lot. Right?
Yeah.
Okay, so next topic. I just wanted to take you to the Juno website because this website is pretty robust. Once again, all the information I learned about this comes from their websites. And you can browse here as long as you want. So if you want to find out more about the spacecraft and instruments, I could go into this and I could spend 2 hours talking about Juno's instruments. But all I would be doing is kind of turning it over and explaining what this is saying. So rather than doing that, I have some better, more interactive things. But let's take a look here at those topics that we talked about. The payload includes gravity and radio science system, 6-wavelength microwave radiometer. Ugh. What does that mean? So you're looking for microwaves. You're looking for which is part of the radio spectrum of light. And Jupiter is very loud. Loud, I use the word loud because we listen to it generally in humans. Use your ears. If you've ever seen the movie Contact, Jodie Foster, they show her at a radio telescope listening on headphones. So when I say loud, that's what I mean. Jupiter is very loud when it comes to radio waves. And a vector magnometer. So this is basically trying to determine the direction of the magnetic field. So it's like a really advanced compass. You've got the strength of the magnetic field and its direction, unlike a compass which would just be what? Just direction, right? So a magnometer is a compass with a number that is associated with how strong is that magnetic field, which is pretty helpful. The gravity and radio science system, to explain that a little bit more, it's trying to find fluctuations in the gravity of Jupiter. At least in previous planets, we found that their gravity is not perfectly spherical. I'm going to turn this off. All right, so the gravity is not just perfectly spherical, and as a result, we can learn a lot about it. And the way they're going to be studying this is, as the spacecraft is flying over, if its elevation changes without touching the engines, we know that something is pulling it or not pulling it as strongly, and that something would be gravity. And that has to tell you something about the internal composition of the planet. So that's really important because one of the main goals here with Juno is to determine what is going on below the surface. We don't know. We've never been close enough to find out.
So it's like magnetic waves, like pulling.
That would be this part.
Yeah.
This would be gravity, which is definitely different. But yes, the magnometer would be magnetic waves.
Yeah.
And in fact, everything that's not gravity in this will be light, which is an electromagnetic wave. And this is actually magnetism.
Ooh.
Okay, like a magnet on your fridge.
Yeah.
Yeah.
Which is once again different, not
an electromagnetic wave. Radio plasma wave detector, once again, waves. The instrument's name is waves. Ultraviolet image spectrometer, looking for higher energy things. This would probably be what you'd look for those aurora. Okay? Yes? Steve first.
Alright. Do you know what kind of energetic particles NASA's interested in?
I would imagine one of the most important things that we want to know is how much charged particles are moving through the spacecraft at any given time. And, you know, there's many reasons. First off, you know, your instruments, just like the human body, are not capable of withstanding immense amounts of radiation without causing problems. A circuit, a computer chip, is not going to withstand a certain level of radiation. So by measuring it, we can do two things. We can understand a lot about Jupiter, but we can also know how to prepare the future, because we plan on doing other missions. And by having that data, we might find out that, well, we overbuilt Juno. Maybe we did, because we've never been here before, and so you wouldn't want to show up with half the shielding, right, that you need. And by shielding, I mean like things to protect the spacecraft from the magnetic radiation, electromagnetic radiation from space. So if we find out that it's not as necessary, then we can build the next spacecraft a little bit less robust, which means you save on weight. And that's really what matters, saving on weight. Because if you can make the spacecraft lighter, everything else falls in place. Your energy requirements, meaning your rocket boosters and things like that, are smaller, and everything becomes a lot more simple. If we find that it's not enough, well, that's a problem, because now Juno is going to probably be in harm's way. So hopefully we overbuilt and we can scale back in the future, or at least keep where we have it at. Otherwise, maybe humans. I really doubt that we'll be hearing, I mean, Mars missions, we're talking about Mars missions. And if you've ever been to one of our discussions before, we did have a Mars one a few months back. You're welcome to watch it on YouTube as well. We have our YouTube page. Mars is a very dangerous mission for humans because there is an immense amount of radiation as we leave Earth. In fact, our people up in the space station right now are much more susceptible to cosmic radiation than you are, and solar radiation. The result of this would be cancer, right? They're at much higher risk for cancer. So as we delve deeper into the solar system, I have a very hard time believing we're going to be going to Jupiter anytime soon, because the radiation environment would kill you within hours. Unless you were properly shielded, which is a lot of shielding. And that's a heavy spacecraft.
You mean?
Yeah.
You mean radiation coming from the sun? Or
coming from the sun, coming from deep places in distant parts of space. Supernova explosions in other stars would be cosmic radiation, whereas solar radiation is from our sun. And Jupiter itself makes radiation.
That was my question.
And because of these magnetic fields, Jupiter is going to cause more, it's like a big collector of solar radiation. Those auroras that everybody thinks is so beautiful, and they are.
Aurora borealis.
They are an indicator of lots of activity in the electromagnetic spectrum, and that is dangerous. In fact, you are at a higher exposure to radiation when you're in the north or south pole of Earth. And if you have aurora overhead, you are receiving slightly, not dangerous amounts, but slightly more radiation than you normally would. Yeah.
So the next mission after Juno will be light with with small radioisotope thermoelectric generators, because I was reading on Wikipedia that other missions that went to Jupiter used those RGs.
Yes, so you're talking about nuclear power versus solar power. Yeah. The decision was made early on here to use solar. Now, it's a very good question. So one of the main reasons why you want to use solar, in this particular case especially, if we're trying to learn more about the radiation environment
to introduce another source of radiation, the actual nuclear power aboard your spacecraft, introduces another problem to your scientific experiments. So by using the solar panels here, we don't have nuclear power on board, so all the radiation we're detecting is from Jupiter.
Oh, so that's why Juno has those solar panels.
That's one of the reasons. I would think, I'm telling you this from the top of my mind. That's, as a scientist, that's how I would want to think about this, is let's try to get rid of any possible, information that we could be gathering thinking it's from Jupiter, but in reality it's just our nuclear power on board. It's like trying to make things as simple as possible.
Yes.
Yeah.
So are you saying that no living soul could ever approach Jupiter because of the massive radiation?
That's correct. That's correct. Notice also that in this image, the magnometer is really far out here.
Yeah.
Right? So they have the magnometer way out here, and if I remember correctly, they have other instruments here inside the spacecraft that are measuring similar things. And so by separating them, just like our eyes are separated, we get more detail, right? You can see depth perception. Close one eye and try to grab an object, or don't try this, but catch a baseball, right? It's going to hit you in the face, right? Because you don't have depth perception. So by separating the instruments, you gain that ability. Right? You get to have more detail because you have that crossing of what information you're gathering here versus pretty far out. We did say it's the size of what, a basketball court? Yeah. That's a lot of distance between those eyes of the spacecraft. The wider the distance, the better data you get. Any other questions? Yes?
So after you're done with the mission with Juno, you're going to smash it into the planet Jupiter in order to avoid contamination with Europa.
That's correct. You're ahead of me. Good job.
Wow.
Yep, that's exactly right. So now that the cat's out of the bag, yeah, we do plan on going back to Jupiter's moons. In a new mission, it's already slated for the budget. Congress, like last year, has it in the budget that they're going to start building the Europa mission.
Europa mission?
To land on Europa, which is the most possible moon for the potential for life. Underneath the icy surface of Europa, with previous missions to Jupiter, we've detected a very vast ocean. The amount of water in Europa's ocean is more than Earth's by many fold. It's over 100 miles or kilometers, I can't remember which one, thick. Now, if you know anything about our oceans here on Earth, we have a few miles of water. At the deepest part of our ocean, it's almost like 7 miles or so. At the Marianas Trench, we're talking 100 miles or kilometers. Once again, sorry, I can't remember which one it is. Thick of water underneath the icy surface, which is also very thick, made of water ice. One of the potential, well, one of the things we think at least would be a prerequisite for life is water. So to travel there, we do our first look into potential life on that world. However, it's unlikely that we're going to detect anything because of that radiation environment. But the neat thing about water is it works like that shielding. So they think if we can go below the ice into that column of water, there could be life on in the oceans of Europa. And the idea is that the life would be occurring at a place called a hydrothermal vent. If you've ever seen, has anybody ever seen the black smokers underneath the deep ocean, where it looks like smoke is billowing up from these chimneys?
Yeah.
Right? Yeah. Yes? Okay. So basically it's an area where we have volcanic activity, and heat is rising from deep below the crust, and that's exiting into the marine environment. We know, here on Earth,
that these marine environments, known as hydrothermal vents or also as these black or white smokers, is one of the main likely places for life to have started on Earth. If life can start in the oceans here, and by the way, no light is down there. How many of you have seen the deep oceans where there's pitch black and the bioluminescent animals, right? Watch Finding Nemo, the fish that has the little thing over its head, everybody knows the anglerfish.
Yeah.
Oh, yeah.
Right? And the lures its prey in with a little light on the front, then it, once the prey comes in.
Yeah.
We're thinking that these are the type of organisms that may be in Europa's oceans.
Whoa.
We don't know. It's very much hypothetical at this point. Now, why is that occurring? That's occurring because Jupiter's gravity is literally kneading, like a piece of bread, it's literally kneading Europa back and forth. And as that occurs, just like the friction between my hands, heat. And so we've got that back and forth, back and forth. Europa's warming up to the point where it's becoming volcanic. And that's indicated by cracks on the surface. We know there's motion of the ice, and there's no other reason for it. There's definitely volcanism below. Yes?
So Europa is a little bit like Io, as well as a little bit like Saturn's moon Enceladus, as well as
Correct.
Neptune's moon Triton.
Correct. And this one is the best candidate for life that we know of, other than Mars.
Yeah, true. So is astronomers are on the search for life in other places in the universe.
I think so, yes. That's definitely been a trend lately. Okay, any other questions before we move on? Yeah, all the way back.
Yes, is Europa spinning on its axis, or is it like stuck like our moon facing?
Europa is in tidal lock. It is always facing one side to Jupiter. So if you folks are Jupiter and I'm Europa and I'm orbiting you, I'm always going to keep one side faced at you. This is called tidal lock, and it's very common. Most moons in our solar system operate this way, and it has to do with long-term gravitational effects that preferentially work in one direction, that goes directly towards and away from the object that it's orbiting. And internal friction, once again, is causing it to stabilize itself in an orbit that is always facing. Now, if you see an object, a moon, that's not doing that, it's likely a captured asteroid. In fact, Jupiter has over 60 moons. Most of them are captured asteroids. We're not sure if any of them have ever been there from the beginning, and we're going to find more about that out with Juno, as well as the Icy Moons Orbiter, and then finally the Europa mission. So there's two more missions coming in the next 10 years or so. Yes?
With the polar orbit and Jupiter's rotation, are all surfaces of Jupiter going to be exposed to Juno?
We are going to be mapping the surface more than once, yes. In its entirety, and that's a good question. We are in the polar orbit for the sake of mapping. So imagine that you're trying to mow your lawn, right? You can't do it all at once. You have to do it in paths, and you do nice straight lines probably, to make, at least that's how I mow my lawn. I don't know anybody who does something different. Okay, everybody mows their lawn with straight lines?
Yeah.
Good. All right, then you know what I'm talking about, right? You mow these nice straight lines. Well, that's basically what the Juno spacecraft is going to do. So as the planet rotates below it, though, the motion of the orbit is just like this. Then the planet spins underneath. It's like if you mowed in the same pathway, right? I'm mowing my lawn.
Yeah.
Right? And then I turn around and I mow my lawn in the other direction, but the ground is moving below me.
Yeah. Ooh.
Wouldn't that be nice? I wouldn't even have to turn my mower around as much.
Yeah.
Right? So Jupiter's turning and we're going around it. And as you spend the 20 months we're going to spend there, all the data is going to be mapped. All of the locations are going to be mapped by all 8 instruments.
Will Juno be higher than all those asteroids, captured moons?
Like I said, I'm going to show you a visualization here in a minute. Okay? I wanted to highlight, there's one more thing on the Juno CAM website, which is, these images are going to be sent out to the public for you if you're interested in photography and images and processing of images. They're going to send them out, and I've listed a number of free software that you can get. By the way, you can get Photoshop for free.
Photoshop CS2, it's old, it's like 2004, I think. But it's 100% legal and free, and you can download it right from Adobe's website. So I recommend this one. It's a pain to install, but once you get it going, it works really well. Second one I'd recommend is GIMP, which is GNU Image Manipulation Program. This is free software as well, not as powerful as Photoshop, it's still good. And then the last one, this is one from NASA and European Space Agency called FITS Liberator. And this is one that takes the data directly off of scientific instruments. When Lane talks about astrophotography, he gets a FITS file at the end, which is extremely powerful for science. And you can actually get this and you can play around with those images. I think it's going to be in another format, but they might have the FITS format as well if you go to the science page. Yeah.
So Juno is going to photograph underneath the Jovian clouds, just like Magellan did as it photographed underneath the Venetian clouds.
Similar, yes, but with many more instruments this time. Yeah. Okay. All right, I have another one here, another quick video. Let's see if I can find it.
While you're looking for that, I just, if you take images of Jupiter, you can actually submit those images, I think starting in October, you can submit them to the Juno website and they will actually use that somehow, I don't know how, but they're going to use that somehow in their science. So if you image Jupiter, that's a good thing to look for.
All right, thank you. So I'm under this website. I'm under the Juno Multimedia Experience, and here you'll see that there's a number of things going on. And I'm going to share with you this one, which is Bill Nye.
The science guy?
Oh, Bill Nye.
So there's a number of them here. I'm not going to show you this one. Notice there are more than one video, and I'm not going to show you them all. I'm going to show you this one, the Bill Nye and Jupiter Superstorm.
The Great Red Spot. The Great Red Spot has been on the surface of Jupiter for at least 300 years. It was first observed by Gian Domenico Cassini 3 centuries ago. And he noticed that it seemed to be a big storm on the surface. It's 3 Earth diameters wide. And it hasn't moved. It hasn't gone north or south in all that time. But we really don't know how deep it goes. Is it a thin feature like a piece of paper? Or is it a great big angry wedge of storm that penetrates deep into Jupiter all the way to its core, whatever inside? We don't know. But this we do know. The Great Red Spot is caught between 2 currents or bands that are moving in opposite directions. It's like a ball bearing between 2 surfaces. As the bands move, the Great Red Ball stays still. Of course, we don't really call it the Great Red Ball. We call it the Great Red Spot. You got to figure the more we learn about the Great Red Spot, the more we'll know about storms on Jupiter and storms on Earth. You weren't supposed to see that.
So I really like this video because I think it really kind of shows you how little we know. And that's a good thing, because scientists need security in their jobs, right? So we don't know everything, and we need to find out more. And so this is a major debate right now. And we're going to find out, I think. Juno's going to figure this out for us, because it can see with its instruments into the planet's interior. We're going to find out, is it, like he said, a surface feature, or does it go deep, deep below? Now, recently, as in last week or earlier this week, I actually read an article, a separate scientific thing that they were doing from actual an Earth observatory,
they found out that the Great Red Spot is actually emitting a lot of Jupiter's heat. So Jupiter actually takes in, I think it's about 2 times, or I should say, it lets go of 2 times more heat than it takes in from the sun, which is really weird. Most planets, they radiate an equal amount to how much they take in. So, you know, we get heat from the sun, it comes into the Earth's atmosphere, the Earth, you know, warms up to a certain extent, and we release an equal amount, or close to an equal amount. Jupiter doesn't. Jupiter is radiating twice as much as it's taking in. And we don't know why. We know it probably has something to do with what's going on inside. But this recent study found that the Great Red Spot was making up more than its surface area's share of that heat being released. In fact, it's what's called an anticyclone. It's going backwards compared to what you would think of as a hurricane. It's not cyclonic, it's anticyclonic. It's going backwards. And it's releasing energy outward. When you look at the Great Red Spot, see if I can find a place in the video where I can show you it. When you look at the Great Red Spot, the higher clouds are actually in white. So think of this 3-dimensionally. This is not a flat surface. Even if he's talking about being paper thin, there's still a 3rd dimension here. This is deeper into the interior of the planet. So this is, of all of the objects we're looking at, or from the surface features I should say, that we're looking at, this is a really important one, not just for the camera, because everybody's like, whoa, this is cool, we want to look at it. Scientifically, this is an important area. So when we're saying, like Rob said, they're going to be using a lot of these Juno cam targets in terms of science, yeah. Because they're interested in the same kind of stuff as you are, and who's been feeding us this information? NASA has, right? So there's going to be a lot of correlation between what the public's interest is and where the science is going to happen, and this is a big one. So you're looking down into this. Now, what's happening here is that air is actually going like that, for Jupiter's atmosphere. It's going outward. And this has shrunken and gotten bigger and different shapes over the past few years, which has confused scientists because we had not seen much change occurring in previous 100+ years. So weird things are happening here right now. That could be good for science. That could be kind of cool to learn about. So I'm hoping in the next few months to learn more about the Great Red Spot. Any questions? Yeah.
So Juno is going to use radar imaging to find out what makes the Great Red Spot go, and what makes all the belts, zones, and other vortices on Jupiter go.
That's one of the instruments, yes. But like I said, unlike the Magellan mission, which just used radar, this has 7 more different ones it can use as well. So in addition to that radar, it's going to also be using those other instruments. Yeah?
Jupiter is known as a gas giant. Now, are they thinking now that Jupiter does have a surface?
That's a great question. So inside of the planet is the big mystery. So I can't really answer that until we find out more. We think that there's a high probability of some sort of structure inside which we would consider to be solid. What its composition is or what it looks like, we're not quite sure. There's a lot of indicators that Neptune and Uranus were much more like Jupiter originally, but that early on, maybe some sort of an impact happened. They've lost a lot of their outer atmosphere. We know that Neptune and Uranus have an interior core, which is considered more solid. So, and it's equivalent to, I think, approximately 10 Earth masses in its mass. So that's kind of what we're looking for. And that would be confirmation of some theories that are out there right now. Because Jupiter seems to fall into that category. It's considered a gas giant as well as Saturn. Uranus and Neptune are considered ice giants, and that has everything to do with distance. They're all considered Jovian, Jupiter-like. And then there's terrestrial, with Terra being Earth.
We've got the Earth-like planets and we've got the Jupiter-like planets. All right, how are we doing on time, Lane? We have 10 more minutes. Are we looking good for outside?
Saturn's in the clear right now, but of course the sun hasn't set yet, so we don't have a good way of finding it.
Understood.
I'm going to go on out now and finish setting up my telescope.
Okay.
So all of you can come out and look, but I'd say until 8:30 or so, we're not going to be able to find Saturn.
All right. So I'll continue on for about 10 more minutes, and then we'll go out to the telescope. Maybe Lane can have a little discussion there about what we're going to be looking at, hopefully. And if not, we can have a Q&A outside. All right. So let's see. Another infographic, bow shock. This is kind of cool. So it's really short. So Juno captures the immense amount of radiation as we pass over a shock wave, which indicates we're getting within Jupiter's magnetic field, and this is the instrument. Background noise, and then all of a sudden Jupiter. So when I said, that this is the amount of noise you hear in terms of the radio spectrum, radiomagnetic waves in the solar system, and then this is the magnetosphere of Jupiter. This is the radiation environment that we're entering. And I'll play that one more time here to give you that.
Okay.
You can think of this like a bow shock from a boat. So as a boat moves through the water, it creates that wave, that bow shock, as a boat enters the water. That's basically what's happening as Jupiter's magnetosphere is plowing its way through the solar system against the solar wind. And that solar wind is being pushed out of the way like the water. Different noise. So this is energy being trapped in the radiation belts. You can think of it like aurora, but on a smaller, less energetic scale. Questions on that? Yeah.
So listening to the Jovians, to the sound effects of Jupiter requires using headphones.
Yes. Now the instruments do a different way, but yes. So here's a quick infographic that kind of explains this process. So radiation challenge Earth, so we leave Earth's orbit, radiation challenge in space, and now we're entering this is the magnetosphere of Jupiter. So it's way out there. It's huge. I forget exactly how big. I think it's 6 degrees in the sky. If you were able to go outside and use your eyes to see the magnetic, area of Jupiter, I believe it's 6 degrees across. So it's about the size of your fist. That's how big Jupiter's influence is in our sky. And we believe it actually extends all the way out to the orbit of Saturn, which is twice the distance from us that Jupiter is. So it is a dominant force, not only gravitationally, but also in terms of its magnetic field in our solar system. And I don't know if this picture shows us Earth's radiation belts in scale. Those are pretty cool. And it does not. Okay. All right. Wanted to show you this one last thing here. I got some other links I'm not going to get to tonight. There's some Science of Juno, a YouTube video here. I recommend you watch that. This is a really long one. This is like over an hour, and this explains everything directly from the horse's mouth. With the horse's mouth being Jack Connery, the principal investigator, which I'm trying to get a hold of. He's from Goddard Space Flight Center in Maryland, and I'm trying to see if he can come talk to us once things calm down for him a little bit, because right now he probably has plenty to do. We'll see. No promises. Okay, the last thing I wanted to show you here, eyes on NASA. Let me find this. Here we go. NASA Eyes. This is really cool. So EYES is a piece of software that you download. I believe it's both for Mac and PC. Don't believe there's an app for phones and iPads and things like that. But there is one for the computers. And what you do, and you can see here, there's different things you can look at. Eyes on the solar system, eyes on exoplanets, eyes on the Earth. Here we've got Juno up as the top thing right now. New Horizons and Pluto also, 2 new missions. We've also got Dawn and Cassini. Events on Earth as well, and much more to explore. You know, Curiosity rover, this is the Deep Space Network. This is like how we communicate with our spacecraft using Earth-based large radio telescopes. Look, mobile apps, I was wrong. Okay, so what I did here is I downloaded this app. And then you click on, once you've downloaded the app, you click on Juno. You can either download or launch. I actually already have this on my computer. So it should launch this. And it'll open up this program called NASA EYES. And I'm downloading this, an update crate. Okay, hopefully it doesn't take too long. And what it allows you to do is it allows you to visualize what's happening with the Juno spacecraft live. And it also allows you to see what happened in the past, as well as what will happen in the future. And I really think this is a fun thing to do, to find out, you know, about those orbits. And I was going to use this tonight to just show you a little bit about how this works. While this is loading, does anyone have any questions for me? We've got about 5 minutes remaining tonight. Any other questions? I don't want to get to you, but I want to see if anybody else has a question.
Well, you were going to talk about how high it is above the surface of the
Yeah, I'm hoping to figure that out right here as this opens up. Yes?
Will it be to map the structures of the clouds underneath the surface as well?
That is the main goal, yeah. We really want to know what's happening below the surface, and we certainly have theories. Now we need to prove them. Or maybe even better, maybe we find that our theories were incorrect, which means we have brand new science to figure out.
Like how the clouds interact with each other?
Yes. Yeah, definitely. And what's causing the circulation patterns that we see. Because all indicators, great, it did work. All indicators are that something is happening below the surface to cause this to occur. Now look, I can play around with this all I want. And there's Jupiter. This is live, by the way, in terms of, I'm sorry, no, it's July 4th. This is the orbit insert. And I can click on this and find out more by going to Explore. And it gives you all sorts of options. Now notice it gives me my options. Cinematic view is what we're currently on, I believe. And this is now real time. So Jupiter's way out there right now. Remember, this is our 57-day or 53.5-day orbit. So we're way out. This will get smaller. Now let's see. I haven't used this as much as I would have liked to prepare. The science of Jupiter. So you can find out all about the atmosphere. You can turn on the magnetosphere. Here's the magnetic field, by the way. I can zoom out. It's the same things as like a Google Maps or Google Earth. You can see the magnetic fields coming out of the poles and into the other poles. You turn on the aurora. Notice they match. There's some of the aurora. And then also on the South Pole. We can turn on Jupiter's rings. Did you know Jupiter has rings? It does. They're not as big as Saturn's, but they are there. They're very faint.
Yeah.
We can turn on its radiation field. Ooh, that stuff that's nasty and can hurt our spacecraft.
Yeah.
And then the interior. And we can actually delve deep below the interior. And I imagine some of this is going to change. Some of this is going to be wrong in a few months. We're going to have to fix it. So that's hopefully why the updates will work, right? And you can turn on different cameras. So your interest was the infrared camera. It gives you the information. You can learn more about the infrared camera. There's all sorts of information. Done reading. You can check out all the different instruments this way. Notice it's just kind of click through. Notice they name them cool things like Jedi.
Jedi.
Jupiter's magnetic field monitoring system is called Jedi. And remember, there's one here for magnetic fields, and then another one way out there, so that we can see that difference like our eyes. Okay? Juno Cam, the one that you're going to be hopefully using. voting on, there it is. There's the Juno can. That's what's looking back at the planet and giving you those beautiful images. All right, last bit here. Let's see if I can find out that answer to answer that question that we had. The Juno mission. So here's mission events. Let's see if we can get this. Jupiter orbited, and look at this nice little slide bar. It launched from Earth, and like literally this follows along with this as I'm moving, time, date, stamped, and everything. Now this is where we are right about now, right past the orbit insertion. You can actually watch that occur. Let's see if it can play here. That's pretty slow. Let's change the real rate to a faster time rate. Plus, please, thank you. Oh, that's too fast. Whoa. Let's try that a little bit slower. Okay, let's see if we can get it to fly by. You should practice before you're in front of people you realize. Oh well. Here we go. So question and answer. So it goes through, should probably slow that down a little bit. It does go through the radiation, or it does go through the inner moons, but not all of them, I don't think. Okay, let's slow this down now.
It looks like a spacecraft from Star Wars.
I'm sure many NASA scientists would be happy to make that connection. All right, so we're coming in a little bit slower than I think we need to do. Let's see. I'm sorry, I can't get this to do quite right. But you get the idea. Okay? One more try here. NASA doesn't get more tries. All right, that was really quick. Facing the wrong direction. There we go. Yeah, it's definitely coming in to an orbit within those moons, but not the closest of them, I don't think. And you know, here's your period reduction maneuver. This is at was it Juno, or no? What do they call that? The Para-Jove 2, I guess it is, or 3. Para-Jove 3. Where they're going to come in now, and they're going to do that burn, and hopefully we see the engines ignite. I don't know how advanced this software is, and we'll call it night after we see that. Or hopefully we see that. So it's getting in. Para-Jove, coming soon, and hopefully burn. Yes, you see it? It was really quick. Okay, they put the burn on, and now notice it's not going to go as far away as it did before. And this is going to be those polar orbits. Notice, compared to the moons in the solar system, it's going up and over the poles and then back down again. It's never, and it's mowing the lawn as it does.
Yeah.
Still in a highly elliptical orbit though, right?
It's in a highly elliptical orbit. Part of that actually is by design, because for two things at least. Number one, it's really hard to make a circular orbit energy-wise with your burning of spacecraft engines and fuel. So that makes it easier for that. Secondly though, this gets us out of the radiation belts when we don't need to be. And you don't want to spend time in those radiation belts. Get in, like I said, get the data and get out. Because it's really dangerous for the spacecraft. And then in 20 months after it starts science, it is going to burn its engines and it's going to drop into Jupiter's atmosphere and burn up, because we don't want space junk, as William, right? As William said, you know, we don't want to crash into Europa, which is our like gem potential, having life on its oceans. We don't want to contaminate it. Okay. Any questions before we wrap up for the night? Okay. I'll take. Go ahead.
It looks like the closest approach is, you know whether it's like 1 Jupiter diameter, 2 Jupiter diameter?
It gives you the distance in miles here. So let's watch for a little while here. 1 point. I saw it drop to under 100,000 miles, which is pretty darn close. Yeah, I definitely saw a 1 there. You can slow it down and find out.
Other questions? Yes, one last question. We got, if you folks want to start moving your way out the lane, if you have interest, he is going to hopefully have Jupiter in the telescope tonight, at least that, and Saturn for sure is out. So, yeah, go ahead.
Can you fast forward to the end of the mission before this meeting closes?
I will do that right now. I'll just slide the little thing here, and I'll slow us down a little bit. Yeah, why not, right? Let's watch the end of its life.
Yeah.
They'll be taking data, I presume, all.
I would.
As far as they.
Oh, yeah.
Oh,
You're not going to miss out the opportunity to get data. Where is that? There it is. Yeah, there goes one. But hey, this is how we have to do things, and there's a requirement now that all NASA missions must have a de-orbit plan. You must, and that's actually something we're trying to make global rules about, because space junk is a problem.
Space junk?
Space junk. Satellites that no longer work. Can you imagine if if this were flying above Earth and all of a sudden, it's the size of a basketball court. And there are things up there that big, bigger than that. The space shuttle is the size of a football field. And, I'm sorry, not space shuttle, the space station. So, if that were to crash into your house, that would be a problem.
Yeah.
And so they make, and even here we go, did we crash yet? Not quite yet? Oh, it's getting close though, isn't it?
Yeah. Oh, yeah.
So, what a way to end, good idea.
Yeah.
So, if we were to have it crash into our planet, in the case of the International Space Station, that could be dangerous. And so we're requiring, they're just going to keep doing this, looping around until we get closer and closer. And guess what? We are, as we were saying, getting better data with each step.
So it's not just one
Look at this.
turn and crash, it's.
Well, they de-orbit, 54, 56 miles away. And this is when we're going to start, it's getting farther. Wow.
You're going backwards, maybe 1 second.
Oh!
Eventually.
Boom! 10 seconds per second. 10 miles, I think this is where we end. Yeah, they ended it there. So, I hope you enjoyed our discussion this evening. Thank you very much. Let's give Axel another round of applause. And have a great evening, folks, and I'll see you outside. Thank you.
You're welcome.
Good questions, man. Very good questions. Oh, awesome. Done. Oh, wow, okay, fun. That worked out really well.
Wait, are you talking about the Spectrum Viz or the Spectrum?
The
Spectrum 20, yeah.
You
didn't know that I could do that for Spectrum.
When we launch. I hope to see you on more. And like I said, we'll have telescopes sitting outside. I'll be out there at home. Great. Stick around.
Spot.
Awesome. Thank you.
You went outside? When you would use that spot, it would be a second.
Well, it was 1 second. It was 1 second off. It's kind of like, hey, I'm going on a trip to California. I'm going to beach, Las Vegas.
Cool.
At 1:36. No, it's not. We're on.
Oh, really?
So we basically like saying
you would need to bring that up to the officers meeting. When is it? What's the date?
get to Las Vegas.
Bring it up for.
I think we can get there.
Bring it up for our. Oh, it's
1
September 11th.
p.m. and 56 seconds.
Okay. Shoot an email to the officers.
Get there.
That's a call I can't make.
12:01.
Okay.
Just 7 or 55. Yeah, it's like,
Okay.
really predictable.
you were there because we gave the items. We
Yeah.
gave the items.
I would say definitely, but I don't know if there would be a cost if we were to be able to do it.
Okay, how?
Anyway,
If it's how accurate. So we do.
All right, you guys stick around and outside, or?
Yeah, yeah.
Okay, I'll talk to you out there, man. Ready? Stuck around.
Well, I'm always happy to.
Hey, Chad, nice to meet you.
Have a good night.
Oh, awesome.
Hey, thank you. You too, man.
We're gonna have one at Muddy Run.
Okay.
It's gonna be on, this Saturday. What we're doing is we're having our own board meeting, it's all for one. We're gonna open it up to some other folks. We'd like to come.
Excellent.
1 o'clock. I think Al's already. That was very interesting.
What's that?
That was very interesting, your talk.
Oh, good.
I just signed up to be a member, I have not heard anything back.
Review it again to see what those is.
All right, yeah.
Okay, okay.
12th to the 13th, I believe it's Friday night. So I didn't realize that before, but